So welcome to today's session. We really want to take some time to talk to you about how you should think about managing your identities when it comes to your GenAI applications. We're going to spend some time thinking about that and the right places to be doing your implementation of authorization. So my name is Lily Ashidam. I'm a security essay with AWS, and I'm with my colleague Arthur today.
Yep.
So with that said, let's get started, okay? So, as I said earlier on, what we want to do today is really highlight what the recommended steps of the best practices or where you should implement authorization when it comes to your identities. But before we get started, we want to level set on some basic definitions, right, on what you should think about when you're thinking about authorization and authentication when it comes to AWS. So, we have a concept at AWS where we have the control plane and then the data plane, right? So the control plane is where you get to say, can I launch an EC2 instance, right? Or can I launch and create an S3 bucket? And in this space, we have really well-defined patterns on access control to say who can authorize what, who can have access to what resource, and who can actually create a resource and other things like that. And when we get to data plane, it really focuses on how your applications would interact with data. So in the example I gave in the control plane where we have your EC2 instance, let's say it's going to be you have an application that wants to have access to your S3 bucket to read or put something in your S3 bucket. How do we really control access when it comes to this space, right? And it even becomes more crucial when you talk about generative AI, right? Because we have a generative AI having access to various amounts of data. So what we really want to focus here today is to really level set on the best way to really authorize when it comes to getting your generative AI to have access to your data, okay? So we have recommended practices, and we want you to think about implementing something we call zero trust when it comes to authenticating and authorizing your users. And zero trust does mean different things to different people, but AWS, we really start with this question that what will be the optimal way or pattern to introduce security and availability to our systems? So we think of zero trust as a security model where we are going beyond the network parameters and just checking for IP address to see where you're coming from to access a resource. But we introduce other layers like identity, asking you, who are you and where are you from and what can you access, right? So having that kind of difference in depth and layers is what we want to think about. So today we really want to focus on the identity part. And this is also very integral when we talk about Gen AI, because when we think of Gen AI, there are two things. The natural language part of Gen AI, right? So sometimes we think that because it's a natural language system, we can say who can have authority to access this kind of data. But we don't want you to think of Gen AI in that space. It shines in other areas, but we want you to absolutely leave out authorization to a deterministic factor when it comes to Gen AI. I want you to think about how you can implement zero trust to be able to do the authorization authentication towards your Gen AI applications. So when we come together to put all of this framework, we see that we are actually authorizing at each layer, from the edge to the perimeter, all the way to the resource. And when we do this, we always make sure that we are asking at each point in time, who are you and what can you access, right? We don't fall on past authentications to give access to a user or to a different kind of identity. So really implementing this ensures that we are having that kind of defense in-depth nature throughout the full cycle of your ubiquitous authentication authorization in AWS. So one thing we want you to do is to think about how we can apply this zero trust concept to your Gen AI application design and what will be when you're translating into the practical architecture form, right? And that's what you're going to really spend today thinking about and talking about. Okay, so before we actually go on to think about how do we do authorization for our Gen AI applications, there's some fundamentals that we want to set in place, right? And to get a fundamental set, I want you to think about this scenario, right? We are continuously revolutionizing, we are creating new things. So imagine you create a state-of-the-art identification and access management platform, right? And then it gives you 85% probability when it comes to authorization concept. How many of us are going to buy that kind of device for authorization? Probably none of us, right? We always want to make sure that when it comes to authorization, we are using a deterministic factor, that 100% of the time we can rely on the authorization context that is coming in. So then when we want to do this, GenAI is not the place to do our authorization then because of its non-deterministic nature, right? Because if we do that, we are going to be getting 85% chance that the authorization concept is right. And we don't want to do that. So we want to think about leaving the authorization to deterministic factors, things that would 100% surely come back to say that Lily is authorized to perform this action or to perform this function. And with that said, we want you to think about really taking one thing from this talk, that when you're thinking of identification, do it around your GenAI application and not from your GenAI application. And that's one thing we want you to really take away today, that when you're thinking of authorizing access to your data, it always should be not from your GenAI application, it should be around your GenAI application. And Arthur is going to really go into depth about how we can apply this concept in your architecture design for your GenAI applications.
Thanks, Lily.
Yeah.
Ready. Good afternoon, everyone. So my name is Arthur Manev. Just a quick intro here. I'm a security specialist, I say, in the same team where Lily is. Today is my 7th year at AWS, so been here for a while. So what I wanted to do is, Lily talked about the do's and don'ts, and that absolutely makes sense. So if you take nothing away from today's session, take the previous slide. Don't let your GenAI, don't give it the authority to make security decisions on your behalf. But the other component there was the zero trust, right? And the session title is about managing digital identity, and all of a sudden we're talking about the zero trust, so where is the connection? And what are some of the components of zero trust that we need to remember is that, one, zero trust is not a service. You can't buy it. You can't click a tick box within the console. This is something that you have to weave into your application from the ground up. Right? Similarly to how you develop your GenAI applications, you've got your development tools on one side, you've got your SaaS applications on the other side, maybe A2A somewhere, MCP tools. So highly distributed components, similar to how you build the rest of your universe. That's one section. The other one is with zero trust, you no longer depend on the perimeter control as being the sole barrier between your valuables and the rest of the universe. So you're now adding identity into it, and the conceptual part here is that with zero trust, and you see this diagram here, which is similar to what Lily showed before. The one before was a generic version, so here's what we think zero trust is. This is kind of a GenAI specific implementation of it. So partly here, what we have is we have the edge perimeter application. We got the orchestration and the data tools, and all of these layers are in between your requester and somebody getting access to your valuables, which is all the way in the end of the line there. One of the things that you see here that's common across most of these components is the deterministic control set, and hopefully with a shared context. The one thing that's not here for deterministic control is that large language model box, which is completely isolated. Why? Because we don't want to give agency to your LLMs to make security decisions for you. So we're kind of removing it from the control set. Let other components, like Lily said, build around your GenAI world. Now, the other element here, why we're looking at zero trust, is passing over the credentials, right? So we're talking about you're no longer dependent on network controls. You're now also you're using the identity. You're passing identity credentials from one stage to the next. And within the zero trust world, the best of the two is not a binary choice whether you use identity or network controls. It's when you use both of them together. Now, some of the places where it comes in is how do you authenticate and how do you authorize access to each one of these boxes, because none of them trust one another. There is no implicit trust that if I'm at the box number 2 that I came through the particular age. So box number 2 treats it as an unauthenticated request. So how do you do this? Well, this is AWS conference, so I'll do a quick plug. So we do have verified access and verified permissions. So AWS verified access, AWS verified permissions. And verified access is great for the edge. And it's a system that authenticates you before you come through. So there is kind of an implicit notion of those two controls, the who and the what, and where also working together. The other one is verified permissions. Has anybody seen this? Just by the show of hands. Has anybody worked? Right. Some. The verified permissions allows you to offload your authentication, your authorization decisions onto an external service within AWS, right? So verified permissions, separate service. You generate a policy in there. You ask it the question, is this user authorized? And you move on. The idea here, though, is that in every one of these boxes, you perform those functions. Every call, every data fetch, you pre-authorize before. And then what that leads to is you can now combine data and logs from these systems, because now they're sharing the same security context. They're using the same or similar systems on verified access, verified permissions in terms of policy management. You're now combining those logs, you're pulling them together, and now your analytics and your security operations center or your Splunks or however you monitor your apps, they now pull all this together and they can work out the entire session, the entire thread how the system works, right? And that's kind of the opinionated guidance from AWS. Now, this presentation will be available online afterwards. There will also be a recording of it on YouTube, if you will want to listen to it. So going through some of the components, the ones that you've seen on the screen, and then we'll go through the entire application flow. So the first one is the actor. That's your application, it's your user, that's your service. And that actor is requesting to interact with your application, right? So the identity at that point might already be known, or it might be just a blank, brand new session. Depending on that, you're going over to the edge. Depending on the tool set that you're using in there, you could use things if you use, for example, verified access. Verified access will request the authentication process that will send you off to whatever the trusted entity is, get the authentication credentials, get the token, and then pass the token over to the endpoint. The endpoint will authorize access and then route you to the back end of your application. So right there, out of the gates, you now have the identity, and you now know how to manage this. And then you get to your application. Well, verified access allowed you through the gates. Your application now takes the same token, now being passed over, validates whether the user has the permission to access the app. And so that's your other section. Then you interact with your application. Your planner now comes into play. You send a query. You chat with your documents as whatever the functionality is. At that point, your planner needs to be aware of what could it potentially use and what other services. So imagine the setup where you have multiple agents, you have a central planning agent, you have multiple agents coming out of it. Those multiple agents, one of them is, for example, get financial information. The other one, create a new insurance plan. Well, you might be allowed as a human agent, you might be allowed to go in and create a new insurance plan, but you can't see the financials. So sending the workload over to the financial agent is kind of pointless because all you will get back is a deny action because, remember, you're passing your credentials with it, and the agent will go out and refuse the work because you don't have access. So if a planner has an understanding as to what the permissions are, it will let you scope down your work and just not generate additional workload on your system. The conditional access, and that's where really things begin to get interesting. Because now your agent just received the work. You need to go out, you need to check whether you can go and get the data first and foremost. So imagine that the backend for your agent is a database. Your reads out of your database are limited to what the user security permissions are. So if author is not authorized to read full table, then you never read the full table. You never return more than what you want LLM to see. Why? Anchoring back as to what Lily was talking about. If your model has seen data, you can structure the prompt. You can't rely on the on LLMs to simply follow your the deny command. Deny is not a good security control. Deny within the prompt is not security control. And then tool invocation. Right, so we've got the garden variety of different methods now, and all of these are evolving. We have regular databases. We have MCP tools, and you can authenticate today to an MCP server, but the authentication between the MCP server and downstream tools, it's still kind of in drafts and proposal stages. So all of that is currently evolving, but the idea here is that the tool that shows as you pass identity to the tool, you don't let the tool do more than the identity is permitted to do. Right? And then this kind of loops around because a tool could be an agent of its own, and then you just restart the entire cycle. So what I'm going to do now is I'm going to walk through the application flow, kind of see where are some of the places what are the right places to authenticate. So we've got the user, we've got the edge, and in here I have two components. I have CloudFront and verified access. Again, this is AWS conference. I'm using AWS tool sets. But from the architectural standpoint of view, it's something on the edge that filters out the bad stuff. And if that's something that's on the edge that can filter out bad stuff, can also do that within the context and understanding of your identity, like verified access can, so much the better. So we validated that, so that's step number one. Step number two, we pass this over to our application. So the application now checks whether this user is even permitted to access the app. And let's say the answers to that is yes, and it potentially uses the identity services underneath, and we talk about identity and access management. AVP is Amazon Verified Permissions. Whatever the tool is, it goes out, it validates, is the current set of credentials permitted to access data? Assume that it is, it goes into the orchestration phase, and at that point, we have one agent in here, could be more, but the principle is the same. Now it takes those credentials, it takes the prompt, and it supplies those to an agent. An agent, in turn, says, all right, well, is this, if you're using Bedrock, that probably would be a Lambda function. But if you use other agents, whatever the mechanism is they're in, the agent goes back to its knowledge base. Now, knowledge base, some of them support native authentication. In some cases, it might be a DynamoDB table. In some cases, it might be a SQL server. In other cases, it might be a RAG. So depending on what the knowledge base is, the agent at that point interacting with the knowledge base needs to have a contextual understanding as on how to pass permissions and how to retrieve data only that this specific user is allowed to see. So if I'm passing auth tokens through on the front and all of a sudden you're using different type of a security system in the back, there needs to be a mapping process within the agent. Then following that, the MCP tools, same idea as in the knowledge base, except it's more complicated knowledge base. You retrieve those dynamically. Those yellowish checkboxes, that means there is kind of work going on as in how those tools get the credentials over to downstream. And then finally, and whenever all of this data is available and it returns to the agent, you send this off to the foundation model, and at that point, the foundation model now acts with the query with the original prompt and the available data. It pushes those two together and gets you the right answer, right? And the stuff that you return back. Right, so again, all of this is going to be available on the web after we're done, but the idea here is that that red box over there, if you get to the red box where you're sending data over to your foundation model, and at that point you need to be able to say, return only a subset because a user is not authorized, this is too late in the process. Right? And then kind of the take-home cheat sheet, as in what are some of the things to do. Right, so it's designed with zero trust in mind. Zero trust is a good security model. It assumes that the application is distributed, right? And if you think about the zero trust conversation, where did it come from? We used to build houses and 4 walls, and we used to put all of those, and that's your perimeter control, put all of our valuables in there, and then close the door. Well, today it no longer works because your valuables are no longer they no longer fit inside the house. You've got a data center application, you've got a SaaS application, you've got an A2A agent sitting somewhere else, you've got an IoT device sitting somewhere else. So zero trust assumes that the application is highly distributed, which fits very well in the context of the agentic workload. Zero trust is also designed in such a way that none of the individual components trust another, right? They don't trust another one. They never have an implicit trust. Again, this is kind of where you want to be. Right? And then use LLM as a planner. Use LLM as a formatter. Do not give your foundational models the agency to control your security. Right? On that note, thank you very much.
Thank you.
And we'll be available off to the side here.
Thank you.